Welcome back. We'll now be talking about graphing quadratic functions in intercept form. So in order to do that, we're going to be finding different parts of the parabola, finding the x-intercepts, the y-intercept, the axis or the line of symmetry, the vertex, and sometimes we might need to find another point or two to help us know what the graph looks like, and then we'll graph the function. So remember, let's start off talking about x-intercepts, and I want to make sure that you remember an x-intercept is where the graph crosses the x-axis. And they look like x comma 0. Right? So whatever our x-intercept is, comma 0 is the point that is our x-intercept. Now our y-intercept is where the graph crosses the y-axis. And the point of it looks like 0, comma y. Okay, so let's use those ideas down here as we're finding these. So let's first start off with these x-intercepts. So we're going to use that zero product property that we talked about in the video previously. And so we're going to set each part equal to 0. So the whole thing equals 0. 0 equals x plus 2 and multiplied by x plus 4. And then we set each of those parts equal to 0 and solve. So x plus 2 equals 0, and then x plus 4 equals 0. When we subtract the 2 over, I get x equals negative 2. And when I subtract the 4 over, I get x equals negative 4. So my 2 points, make sure you write these out as ordered pairs. I'm going to have 2 comma 0 and also negative 4 comma 0. Those are my x-intercepts for this graph. Okay, let's go and find the y-intercept now. So the y-intercept, right, our x is going to be 0, and then we solve for y. So remember in our graph, our f of x is the same thing as y. So if you want to think of it that way, it might be easier. So I'm going to have y equals, and then in place of my x's, I'm going to put 0. So I have 0 plus 2 and 0 plus 4. And 0 plus 2 is 2, 0 plus 4 is 4, and 2 times 4 is 8. So y equals 8, but we're not going to leave our answer like that. Let's write it as an ordered pair. So when x was 0, y is 8. All right, now the line of symmetry. So a cool thing about parabolas is their symmetry. And remember how we said the vertex goes right through the center of that parabola, and so the line of symmetry is going to cut through that vertex. So if we can find exactly halfway in between these 2 points, we'll know where the vertex is. So let's take our x and let's add our x's together that we found. So we found that x was negative 2 and negative 4. And then if I divide that by 2, that's finding the average between those, which is going to give us that point that is right in the middle of the 2 of them. So then this will simplify to be x equals negative 6 over 2, or x equals negative 3. Now remember, this is a line. It's the axis of symmetry that cuts that parabola exactly in half, and it's also the x-coordinate of our vertex. So let's use that for our next part. So remember, if I'm trying to find this point, the vertex, that negative 3 is going to be the x-coordinate. And then to figure out what the y is, I'm just going to replace negative 3 into my equation in both places of x and solve for y. So we'll have y equals parenthesis -3 plus 2, and in the other parenthesis, -3 plus 4. Okay, let's keep simplifying here. -3 plus 2 is -1, times -3 plus 4 is going to give us +1. I multiply those together, I get -1. So here is my vertex, -3, -1. So I have some points here, I have the axis of symmetry, and we want to go ahead and graph that on the grid that we have here. All right, and here is what the graph looks like. We've got our x-intercepts graphed there in blue. We've got our y-intercept in purple. We have our vertex in green. And then remember this axis of symmetry. And we want to make sure that we always label what that is. And that is the line x equals -3. All right. Now let's talk a little bit about maximums and minimums. So we want to state whether this graph that we're looking at now has a maximum or a minimum. Well, we can see that the graph starts here at the vertex and goes up and out forever, right? Those arrows are telling us it's going up and out forever. So there is no maximum point. It keeps going and going and going. But there is a minimum. So on a right side up parabola, that minimum is always going to be at the vertex. And so we can say that this has a minimum, and the lowest point of the graph is -3, -1. I hope that was helpful.